So after we had that initial web tool, we sort of came back, or at least we came back to the Grasshopper tool to say, now that we have a good interface, we know we can share it, we know it can give us quick information early in design. Well, actually, as we even started to apply that on projects, we realized we may have cases that aren't governed well by this tool. For example, I mean, while we can simulate almost any 2D rectangular window pretty well with between all the geometric inputs on the web tool, as soon as you have like a crenellated facade like what you see there, it may not be as good of a representation, or you may want something else. So we realized that now that we had a good sort of fast, simple, basic tool, web tool, that we can maybe now have a slower, more advanced, or able to account for more complex situations on the Grasshopper end. Okay. And that we could really tap into the 3D capabilities of the Rhino Grasshopper interface with that.
So as you're saying, the big idea here is in the original tool, you're assuming you've just got a flat, straightforward facade with a really simple window that's being repeated all over the place, and that's your study. But here you're saying, well, a lot of buildings aren't that simple, and so here's a way to handle those situations.
Yeah, and it could even be one building, but maybe you want something really early in design that's kind of quick, just rules, not rules of thumb, but kind of quick early numbers as targets, and then as you develop the design, you want to get more into the details, and so you can kind of have a quick early one versus a more detailed one for design development.
Okay. And so you can come up with, like, the idea is you get a general strategy. You can say, all right, I know we need to do punched windows if we're going to have double glazed, if I want to be able to remove perimeter heat. You can do that quickly with the web tool and find that out for your climate. Okay. And the other one is not really meant to do the fast iterative stuff. It takes 30 seconds to run, but it can handle a whole bunch of other types of situations.
Okay.
And so we had the idea also with this dual support, this dichotomy that we'd have like sort of basic quickly toggleable inputs for everything on the web tool that were easy to change things around. And the Grasshopper tool would be, for those of you who know Grasshopper, it's component based. And so that allows, it's a set of functions that are each wrapped in their own little component that has inputs and outputs. And this allows you a lot of flexibility. So for example, if we wanted to take results from an energy model and plug them into our tool, you could do that with these components by plugging those into the right input. Or if you wanted to visualize different outputs in a different way, it just allowed this flexibility that you wouldn't necessarily as easily be able to get with the web tool.
Okay.
And also the
the ankle draft discomfort components.
Yeah. Yep. Those were all, by the way, components that we made for the tool and that are now part of Ladybug.
So when you download Ladybug, they come.
Yeah, that you can get these yourselves and mix and match them to solve other problems that we haven't thought of yet.
That's awesome. David Rutten never knew that there would be a component called the ankle draft.
The ankle draft discomfort component. Okay. Yeah, speaking of bad names of the tool, some of my components are like, really the shade benefit evaluator, it's like, That's awesome. Anyway, but I gotta hire someone to figure out better names.
Those are all make great T-shirts, but anyways.
All right, and the idea also with this dichotomy, we'd have like JavaScript would be the main thing that's under the web tool. That's the code under the hood. And for that, we're borrowing a lot from the center of the built environment. We're actually taking their comfort functions and using those in our web tool. And that's also another reason why it's open source, because their web tool was open source to begin with, and so now we're building off of that. So I mean, we now give that back, as under the same open source license. And similarly, and so you can actually, we want it to be very accessible if you did want to look into the code. So in your web browser, you can check it on the web tool. And the components on the Grasshopper tool, you just double click on a component and the code pops up. It's all within there. And we're building off of Ladybug's functions, as I kind of already mentioned. Some of those open source capabilities that are already there. And some of the other differences, like whereas in the web tool, we needed a very fast geometric calculation, we're using the same thing that we did in the Excel, which was a single formula to calculate these solid angles, which then you can translate to a view factor. And it's super fast, but it has a notable limitation where it only works for rectangular windows or rectangular walls. And so as soon as you don't have that, as soon as you have a triangular or trapezoidal window or some space that's different, or a surface that's going to block your view to another one, you can't really use that. And so that's why it was good for the web tool, because it's very fast. But on the Grasshopper tool, we said, let's make this handle any geometry we can think of. And so we use a different method called ray tracing, where we simply project like hundreds of vectors from each and every point that we were interested in looking at comfort. And we see where those vectors intersect. And we say maybe we got 50 intersecting with this surface, 50 vectors. We divide that by the total number of vectors, and you get a view factor. And so it's much more time intensive because you're computing hundreds of intersections, but you can do any geometry. You can do geometries in front of other geometries. It's a lot more freedom, so we can handle different types of cases.
Okay.
And we did the same thing with the downdraft, that there's a simple formula or function, very quick to calculate for the web tool, that is just looking at what is the airspeed in front of the window. Whereas on the Grasshopper tool, we said, let's make this handle all different types of windows. So you can do plane intersections with the different types of varying window height windows and get different heights to plug into that formula. You can calculate the spread of the downdraft over. And all this, I know I'm getting very nerdy here into like geometry nerd land. But all of this was in the next slide was just to give us, now we can get these nice like false color maps of radiant temperature and of airspeed and of comfort, maps of comfort over the floor in percentage of people dissatisfied. For all these different geometric cases, and you can see, okay, as you go into a corner, it gets really cold because you've got two glass surfaces that you're radiating to, and et cetera, et cetera.
These diagrams here,
yeah,
PPD, percent of people dissatisfied.
Exactly.
So these are mad people.
Yeah.
So more is worse.
Yes.
So
yeah, and we made them blue in the in these diagrams to indicate it's too cold. Because
yes.
it's a winter comfort
it's too
tool.
cold. Got it. Okay.
And so and the red temperatures means that you're nice and comfortable.
Okay.
And nice and comfortably warm.
Okay. Cool.
Yeah, and so you can see, it's still, all Grasshopper scripts are never immediately readable, but at least you can tell from our previous iterations that this was much sleeker, simpler, because we wrap things into, components dedicated components that do the functions, rather than having like 50 or 60 native math Grasshopper components to do a certain function. And we can do things like, plugging in energy model results to a Grasshopper tool. Honeybee allows you to build these full building energy models or test box energy models. So we could say, like, one of the things that immediately we were wondering, because we do a lot of radiant floors especially in like kinds of atrium spaces. And at least I was curious, how does that really mitigate the discomfort a lot? And I could take the results of an energy model and use those surface temperatures and everything from that in the tool, because it's a Grasshopper tool, and you just plug those in as inputs. And you can see it helps much more than an air system, which is the fan coil units there.